let's start off with a very quick introduction in the meantime, till
Yeah.
everyone joins in, and then we can take the session forward.
Yeah, absolutely. So thank you so much, folks, for chiming in today. I'm Tanay. I take care of everything technology at ProBlock. So my background has been in generative AI I've been working in the same field for around 7-8 years now. One thing that I like to brag about, and even to a couple of our previous company investors, is that I've been in the field ever since it was called deepfakes. So initially it was called deepfakes, and then people started talking about synthetic AI. Now it's through generative AI. And there are mixed opinions about this. People believe it is a hype cycle. I am not one of those believers, but I do have some opposing beliefs at a couple of other places. So today we'll be talking about, first of all, before even starting, what I want you guys to leave the session is with an intuition of how these systems are built, so you can understand their common pitfalls, and then give you a sense of where we are heading. So we'll go back to we'll start as basic as what are LLMs, or things like why do we even need to train them on the internet, right? We'll start with these fundamental questions. I have a couple of small cool demos I can show you, so you get a sense of what we are dealing with here. And then going forward, we'll talk mostly about business. We'll talk mostly about unit economics, because again, everyone knows the cost of building Gen AI stuff is decreasing day by day. But what most people miss out is the data on unit economics. Is it scalable? Is it feasible? For 10 API calls, it won't charge you anything. But let's say what happens if hypothetically your platform gets 10 million users. Things start breaking, GPUs start melting, and what happens there? How are you able to maintain those margins, those profits, and all? We'll talk about building your LLMs versus fine-tuning your LLMs. And then we'll also touch a bit upon what are the common flaws that we have in the system. And finally, we'll conclude this with how I think about designing these systems. So a lot of things on the store, and I hope so. This is mostly like a geek sort of a talk, but I'll try my best to make it a bit enjoyable. You can quickly start a screen share. So again, welcome guys, formally again. Let's start with okay. So I was asked to make a deck, but then I thought making a deck will consume more time than me researching about a couple of things. So I decided to go with vanilla pen and paper. It's my level equivalent of pen and paper because my handwriting kind of is very bad. So okay, let's start. Okay, let's start with the basic intelligence paradox. Okay, the thing that we should start with is what are LLMs, right? I think everyone knows the LLMs are trained on the internet. Everyone knows here that LLMs can, predict the next words given context of other words. Everyone here, I think, has at least once in their lives used some sort of a generative system like ChatGPT, Gemini, Claude, VS Code. They just keep on growing exponentially, right? So what I want to start with is the learning, right? So basically, essentially, there are two types of learnings. One is called supervised learning and one is called unsupervised learning. So for the longest time, what we used to do to train machine learning systems was we had a lot of data and then we also had labels. For example, if I were to build a spam detection system, right? This is an email. Is it spam? Yes, this is spam. This is an email. This is not spam. Email, spam, email, not spam. So I used to have a lot of this annotated data, and then I used to build models on top of them, right? And doing this kind of guaranteed me that whatever model I'm ending up with will perform very good on email classification, right? Because that was the data it had seen, right? And this, in our jargon, it is called supervised learning, wherein you are supervising the machine as it is learning. You're supervising the machine with labels, right? Or the actual or the ground truth, whatever you want to call it. And there were a couple of problems with this, right? The first problem was finding data was very, very scarce, right? For you to build a very, very good spam detection system, you need to have a lot of people sit and annotate, hey, this is a spam email, this is not a spam email, right? Or maybe if you're building a cat classifier, you'll have to have hundreds, thousands, millions of images of cats and equivalent maybe dogs. Hey, this is a cat, this is not a cat, this is a cat, this is not a cat. So finding these data points and labeling them was super hard, right? And the second big problem was they were not general. I cannot use a cat classifier to classify emails, right? So for every task or every problem, I had to build these models. I remember this. I think I was taking one of these Coursera specializations when I was in my college, maybe 2017-18 sorts. And they had a slide. It was like a Google machine learning specialization or something. And they had a slide that went something like Google had more than 10,000 machine learning models in production at that time. Don't quote me on the number, but maybe thousands, right? And what these thousands of systems were doing very, very simple, minute tasks, very, very small tasks. Things like, hey, if I search something like coffee near me, and there's like a chai tapri nearby, and then there's also Starbucks, where should the algorithm send me? Or what result should be shown first? If I'm rich, then most likely it will direct me to Starbucks. If I'm not rich, it will maybe take me to that tapri or sort of a small sort of a gourmet cafe, right? So this was there. But what happened was, and then again, how do you also solve for problems where you do not have the data? You definitely do not have a lot of data for a lot of problems. Things like cancer detection, things like translation, right? If I have to translate something for English to maybe say, old Hebrew or maybe Sanskrit, I do not have ample data. What do I do? Right? So this is what OpenAI bet on. Okay. So if right now we're in 2025, if we go back to maybe 2015, 2016, when OpenAI was set up, when we had all of these brilliant folks, we had Ilya, we had Mira Murati, we had Ante Karpathy, we still have Greg Brockman, of course, we have Jan Light, we have Andrew Chen, we have a lot of cool researchers. So what they did was they came up with a very simple hypothesis, right? And I think that hypothesis is something that most of us have heard at least once, right? Richard P. Feynman said that what I cannot understand, I cannot create, right? Okay, whenever I'm trying to teach someone something, I need to understand it first. So one corollary of this is what I can create, I can understand, right? So people started saying, hey, if I'm to model language, or if I'm to do all of these language related tasks, which is spam detection, which is maybe creation, which is maybe translation, which is summarization, which is a lot of things. What if I just create a model that can generate good English? Maybe because it is generating coherent English, what if it also understands the semantics of it? Maybe it also understands the grammar of it. Maybe it also understands the relations between nouns, pronouns, proverbs, so on and so forth. And I think that was the OpenAI bet, right? I think they first saw it in an RNN paper, which was, I think most of you would have heard if you are from an academia background, that they were trying to generate Amazon reviews, and they were able to find a specific neuron, which if the value of that thing was 1, the review came out to be positive, and if the value was 0, the review came out to be negative. And they thought, hey, all this is doing is generating fake Amazon reviews. What is this specific neuron doing? Is it understanding? Does this neuron have the idea of understanding of this is positive, this is negative? Because again, no one ever showed anyone anything, right? And this is how the race started. They created GPT-1, they created GPT-2, they created GPT-3, Llama, Anthropic, Claude, 3.5 Sonnet, Opus. We have that entire thing, right? So what essentially everyone was doing was they were taking internet data and they were training their models on it. Now the question is, where do I get the internet data, right? How do I get it? So basically, there are a lot of organizations, non-profits, who take random snapshots of the internet and they collect it into a computer. So you have all of that data. So what I want to show you is when you train that model on that data, you end up with something called a pre-trained model, right? And I'll show you in a minute how a pre-trained model looks like, and maybe even we talk to it. So what that data is something like an autocomplete but on steroids, right? All it is doing is predicting the next token. Because again, let's say the internet data said something like the, intelligence, and paradox. So I know that, hey, whenever the first word is the second word is supposed to be intelligence. When the first two words are the and intelligent, the third word is supposed to be paradox. And if I do this for the entirety of the internet, right, you will end up with something called a Bayes model, which is nothing but an autocomplete, right? Maybe I can show you one open web data set. Open web text. Data set. Okay, it is too big actually. Maybe we can do find against this. Yeah. There is a blog post. So this is a recent research by Hugging Face. What they've done is they found out all internet. This is 44 terabytes of text that spans 15 trillion tokens. We are not here to, I'm not here to formally explain what tokens are, but a good analogy would be 15 trillion words. That's I think mostly. So, and these are some of the classes. So they've also done some topic modeling that says there is some politics data, there's some culinary data, and this is what it looks like: Tuscan grilled chicken, Carabas recipes, intelligence, so on and so forth. Right? So this is what you end up with. Now let's maybe just go and see, when you train a model on the entirety of the internet, what happens, right? So this is what I'm using here. This is Llama 3.1405B base. This is one of the latest models, but this is a base model. This is not what you would interact with when you are using Meta AI. The Meta AI chat on, I don't know, I think they've even recently added on WhatsApp. Okay, so let's do something like, what is the, or maybe let's do something like, yeah, what is the capital of India? I'll just do 64 tokens. Yeah, I think this is it. Okay, cool. Okay, it just takes time. Maybe the servers were busy. Yeah, okay. So I just gave it like a predefined prompt, which is the capital of France is. Ideally, if this were ChatGPT, you were expecting an answer like, Paris, but it started writing, right? Because it is nothing but an autocomplete. So it will try to find it will try to write like it saw an article. I'll just stop this and maybe give it the original thing that we initially had. And let's see what is returned here. Okay, yes. A, the capital of India is New Delhi. Quiz, what is the capital of India? Where did the name India originate? What's the population of India? Then it just starts babbling around something. And now, what I want to tell you guys is, training this foundation model takes around 8 to 10 months, right? And then they spend an upward of, hundreds of millions of dollars. Now, the question that all of you should be asking is, who's paying hundreds of millions of dollars for this garbage? Right? This is not even like, this is nothing. I don't even know what this is buying. I just asked a simple question, what's the capital of India? And I was expecting Delhi or New Delhi, whatever. And then it keeps on talking and talking and talking, right? So what these people found out, right, in the research papers, what they found out was this had some emergent capabilities. By emergent, I meant, okay, maybe let's take a step back and understand what emergence is. See, I think all of you know that fish live in the ocean and sea and lakes and all, right? And there are schools of fishes that kind of go around, groups of fishes that go around doing stuff here and there, right? I think I'm one of those guys who love finding them. So if I'm looking, if in a cluster of fish or in a school or group or whatever it is called, if I'm looking at the fish that is in the center, it does not know what is ahead of it, behind, right, left, up, down, right? All it is doing is copying the fishes to the right, left, up and down. If the entire swan moves right, the fish will move right. If it moves left, the fish will move left, right? So that fish is not intelligent, but as a whole, they are showing some intelligence, which is enabling them to, get rid of prey or predators. Same is with ants. Ants alone don't do anything, or bees alone, they don't do anything, but in a colony, in a hive, they are able to show some intelligent behavior. Like there'll be some bees collecting honey, there'll be some bees taking care of the young ones, there'll be some bees taking care of the queen bee, so on and so forth. That is emergence. The same type of emergence we are able to see here. That it is able to do some things. And maybe let's try an example. Something like, let's maybe try translation, right? So water, pani, okay, and what else? Paper, kagas. What else can I do? Fan, pankha, bed. What is bed called in Hindi? I don't know. Duvet.
It's called a whisper.
Yeah, chadar. Okay, and let's say bed. And I just say, and I ask to autocomplete. Let's say bed, palang, sofa, table, maze, chair, kursi, mirror, aina, door, darwaza. Okay, we can just stop it here, right? So now there was nothing in the entire internet that had something like this or specific example, but it is still able to autocomplete, right? Which I feel is super fascinating. It's able to translate. You can even give it sentences in English and then ask it to translate in Hindi. And this even still does not have a very good value, right? What people also found out was it is able to do something called in-context learning, where you could give it a prompt and then it could do some sort of behavior. So I could do something like, and let's trick this base model, which is not like ChatGPT, into believing, hey, you are ChatGPT and then you are supposed to answer my questions. And this is actually how I programmed Text DaVinci 003 back in 2021. It feels very old now that we have come so far, but this is how we used to do it. I'll say you are like, so this is a conversation between an assistant, a helpful assistant, maybe a helpful and a human. Please, the assistant answers question. Okay, human. Hi. How can I help you today? I want to know is the capital of India. Okay, I'll just say assistant. And then that's it. Let's see what this is. Maybe a space. Yes. The capital of India is New Delhi. Now it started acting a bit in the conversational way. Then it's like, okay. Then it started completing random stuff because again, this is like an instruction. It is not an instruction tool model. It's a base model. So yeah, what we also found out was you could believe this into tricking this as an assistant. If I were doing some sort of programming, what I would do is I would just split it by the next human thing, and then I would take this and I would print it in the UI, and then this would keep going on and on and on and on. And this was, I think, something that was very revolutionary for everyone. So we have covered why learn from the internet and the OpenAI bit, right? OpenAI bit everything on this. That what I can create, I understand. This was the simple thing, and I think there's a very good talk by Mark Chen. Mark Chen is the head researcher or chief research officer, something like that, at OpenAI. You could watch it. It's by Stanford Research. Again, now the question is, now we are saying, hey, these systems are able to complete stuff. They're also able to understand stuff, but are they even intelligent? Right? Do they have real intelligence? We are talking about reasoning models. We're talking about RLHF, nursing, and everything. But do they actually have some sort of intelligence in it? And the best explanation I ever came across was by Ilya. Ilya is one of the co-founders of OpenAI, who exited recently. The same guy who ousted OpenAI from the board, I think last year, and started his own company called SSI, for Super Safe Intelligence. So Ilya said, okay, let's just imagine for a second, we are reading a detective novel. Okay, a detective novel usually starts with, there's a plot, there's a premise, there's a murder, there are user interviews or maybe alibi checkings. Everyone says, I was here, I was there, I did this, I did that. The detective will ask a lot of questions and everything, and maybe at the end it will be something like, and the murderer is, right? What if I fed this entire thing, the entire novel, to an LLM and then asked it to predict who the murderer was? And it's very likely it will give me the correct answer, right? Let's say, hey, the murderer was maybe, in a hypothetical scenario, Adam. I hope there are no Adams in the call right now. No offense, guys. So Adam, right? And it will say Adam, and then you will be like, hey, how did this know, right? So again, the core thesis here being, generation is understanding that if you do not understand anything, or if you do not take anything from this webinar, just take this specific word. What I can create, I can understand, and that's the basis of literally everything that is happening right now. So this was that. Okay. Intelligence. So we have covered that why we need to learn from internet, because we have a lot of data, and then if I show that data to LLMs, bigger LLMs, I keep getting better performance, and this has been scaling ever since, right? We spoke about the OpenAI bit, wherein generation led to understanding. We saw some examples wherein it was able to generate. Okay, one more thing actually I wanted to show you. I think I remember this from a Karpathy or someone video. Maybe let's just open Mount Everest Wikipedia. Right? Let's just see if I just give it something like this. What happens? Will it be able to complete Wikipedia? Let's see. Ready? Send. The highest point elevation rank, prominence rank. Okay, I think this is. No, okay, this is not supposed to work like this. Maybe I'll try this again. Maybe with this. I'll give it a bit more here. let's see. Yes. This always works. Okay. Approaching the summit from southeast in Nepal, known as Sanai Road, and one from the north in Tibet. Approaching the summit from southeast Nepal, known as Sanur, one from the north in Tibet. While not posing substantial technical challenges, Everest basic danger, altitude sickness, weather, and wind. While not posing significant technical challenges, the standard route, present dangers, altitude sickness, and wealth. This is interesting. As of 2019, over 300 people have died on Everest. As of May 2024, 340 people have died on Everest. So because when they were training this model, I think the data was only up to 2020, which is why it does not know. So it also memorizes a lot of stuff. So if you give it things like, we the people of India have solemnly decided to do something that the constitution will, it will be able to recite it word by word. So yeah. Okay, let's
I think we have a question from Tejashri. She's asking that if this is a paid platform, what you're using.
No one needs to use any base models anyways, right? I mean, if you want to play it out, you can just go to hyperbolic.xyz, sign up, verify your number, and you get $1 in credit. And I think that will be more than enough for you to test out any model that you want. I'm not on a paid plan. I just verified my phone number and then I got $1 in credit. Cool. Any other questions?
No, not as of right now. We can continue.
Okay, cool. So yeah, if we now we have this model, which I know I can trick into believing an assistant. It is an assistant. I know it is memorizing a lot of stuff. I know it has emerging capabilities like summarization, translation, so on and so forth. Now, how do I make that piece of junk, which I spent hundreds of millions of dollars, into something that I can host as a model or an API and make some money, right? Which is where fine-tuning comes into place, right? When you're fine-tuning a model, what you effectively want the model to do is ask follow-up questions, okay, have some personality, and also have a sense of knowledge cutoff. Okay, and maybe even diffuse some questions. Something like if I ask, hey, how do I make an atomic bomb at home? And it should be like, hey, as a large language model trained by OpenAI, I'm not allowed to do all of these questions, right? It should ask follow-up questions. Things like, let's say if I ask, what should I wear today? It should not just say you should wear a suit. It should maybe ask, hey, are you a male or a female? Okay, are you dressing casually or formally? Right? It should ask a couple of these follow-up questions so it gets better context. And it should also have a personality so you feel you're talking to a human. It should do things like say things like sorry, thank you, right? It should be conversational, it should be cheerful, the tone should be cheerful. So one more thing that I want to show you is, so first let's maybe talk about why do we need refusals, right? Let's say I go back here again and say the winner of general elections in India in 2030 are. Okay. This is a valid English statement, and I can ask an LLM to complete it, right? Let's just ask the model to complete this a couple of times. Let's reduce this to 64. Let's see. Announce the newly elected Prime Minister of India is a 42-year-old young man. He has an MBA from a reputed preschool and worked as a management consultant at one of the national firms. Okay, this is one completion. I'll just maybe ask the same question again. A, Congress, B, BJP, C, Aam Aadmi Party, D, regional parties. Answer A. Okay, it thinks that Congress won the 2030 election. Maybe let's try again. Okay, something similar. Oh, it's BSP this time. Oh, this time it's also Congress, right? Again, we don't know the future. Okay, no one knows the future, and what we want the model to do is kind of say, hey, these are the type of questions that are not allowed. Okay, this is something way ahead in the timeline I do not know. And if you talk to ChatGPT today, it will say something like this. But because this is a base model and it does not have any guardrails, it will just complete whatever you throw at it. It won't have any concept of refusals. And this basically what we call is hallucination. The model is hallucinating facts, or the model is hallucinating truth. So yeah, we also need to have some follow-up questions. So what people did was, what OpenAI did actually, maybe we can talk about OpenAI. They came up with something called InstructGPT, which were instruction tool models. And what they did was they had a lot of humans sit down and then they asked them, okay, what are the type of questions you would like to ask an assistant? Write these questions, write the answer to these questions, and then also write follow-up questions and their answers. So there's something called Open Assistant Dataset. Yeah. So here's an example which says, can you write a short introduction about the relevance of the term monopsony in economics? Please use examples related to potential monopsony in the labor market and cite relevant research. This is what a prompter asked, and this is what the answer. Sorry, my bad. This is what the assistant should reply. Monopsony refers to something. Then the prompter said, hey, now explain it to a dog. The assistant is like, I'll do this. Then it asks, how can one fight back when a monopsony has been created? So on and so forth. You have a lot of question and answers. And then you show these questions and answers to the model again. And now what you end up is something similar to ChatGPT, wherein it can do some sort of question and answers. And this is how they do it. I think all of you would have heard news about OpenAI hiring a lot of people in India, in labor markets, India, Philippines, Africa, asking them to annotate their data, right? This is also one of the reasons the double hyphen thing shows up a lot of times in chat. This is also the reason the word delve shows a lot in chat, wherein people say delve is not a normally used word, but ChatGPT is using it because someone wrote that answer that included the word delve. So yeah, this is there. So so if you ask, so these data sets would not have all the questions mankind would ever ask. These would maybe be 10,000 questions or maybe 1 lakh question, 10 lakh questions, but there is always a new question that people can ask. And by that corollary, the model will still answer it. And what we say is that is an emergent behavior. So there's a very good article by New York Times or the New Yorker, which goes something like, ChatGPT is nothing but a blurry JPEG of the internet. It is a representation of how our internet is and what sort of things lead to building. Right? And maybe that's the next thing, right? Okay. So next thing that you do is you take the model to school, which is how you end up with something like ChatGPT, right? So again, let's go back to how we used to learn things at school. We had something we used to read. Let's say we are reading a math book, right? Maybe NCERT or R.D. Sharma. It will have some text that will teach me how to solve what the theory is. I'll have some sample questions that will teach me, okay, this is the question and this is how you solve it and this is the answer. And then there'll be some exercises wherein I'll just be given a question and the final answer to this. There won't be any intermediate steps, right? And this is how people think about teaching or taking LLMs to school. Pre-training or making it what the entire internet is equivalent to me showing it the text part of it, right? Hey, this is what the theory looks like. Giving these questions, the open assistant questions, the one that we are seeing here, they are more like, hey, this is a question and this is how you're supposed to answer it. And then whatever questions you give it, they are some sort of test questions, right? And then you can do some sort of fancy fine-tuning basis rewards, which is basically called RLHF. So all of the models that you talk to today are RLHF, reinforcement learning through human feedback. So the basic idea here is how to think about when you're talking to an LLM, right? Let's say I'm talking to an LLM about a research paper ad. Who exactly am I talking to? So the simple answer to this is you are essentially talking to the same guy who wrote a similar prompt for the dataset, for creating that dataset. That's what it is. Which is why you do things like, you are maybe Andre Karpathy or you are Bill Gates, give me a business plan that will generate me $5 billion. Or maybe for an SEO, you do things like you are Adam Grant or, you are Neil Patel, give me interesting SEO keywords. And which is why these things kind of work very, very well. Right? So whenever you're talking to the model, you are essentially talking to some data annotator who wrote something similar. Now we are kind of moving from the theory part to the actual applications. I think I've given you enough theory. It's like we covered pretty fundamental stuff for the past like half an hour or something. We covered why we need to learn from the internet data, because we understood that we cannot have labeled or annotated data for everything. We just betted on the fact that if a model is able to generate something, it will also be able to understand it, which was primarily language, right? Then we looked at some scaling laws. We saw that as the model sees more and more data, and also the model grows in size, it is able to have better capabilities, right? Something like reading comprehension, things like translation, things like, even talking like an assistant. We saw a small demo at Hyperbolic by chatting to Llama 4.1 peoples, right? Then we understood what we have right now is a piece of garbage, right? Because that cannot be put into production, because that's going to spread misinformation like crazy, right? I think we also spoke about the 2030 Indian elections, and then we got different answers. So what we understood was, before putting this thing into production, we need to do some sort of fine tuning, right? We need to basically add two things. We need to add the capability to ask follow-up questions, so that if I say I want a pizza, the model is not like, hey, here's a pizza. It should ask me questions like, do you want a small pizza or a large pizza? Do you want pineapples on a pizza? Do you want paneer pizza, or I don't know, do you want pepperoni pizza or chicken pizza? Right, that's the follow-up questions. You also need to have the model have some personality, so that it does not feel that you're talking to a robot. Things like hello, thank you, basic conversational sort of chit chat sort of things. And then we also understood the concept of knowledge cutoff, right, and refusals. So it should refuse questions answering any questions that are about the future. It should refuse questions that are that are harmful to the user or society in general. Things like, how do I make a bomb? How do I clean blood stains, so on and so forth, right? And looking after all of this, we were able to get to a conclusion that ChatGPT or all of these language models are nothing but a blurry JPEG of the internet, right? The way you have these follow-up questions is by having some person sit and write all of these questions and the answers, and then showing that to the model, right? Then we spoke about taking the model to school, wherein we saw when I'm learning something, maybe from an R.T. Sharma book, I'll have some text that will be the theory. I'll have some practice questions, which will be both questions and answers, and then I'll have some exercises, which will be only questions and their solutions. No middle steps, right? And the equivalent to this is me showing the equivalent to me reading theory is me showing the LLM entirety of the internet by saying, hey, this is a theory, and this is how you should pretty much think about. The solved questions or solved examples, sample examples, are something like me showing it that data set where it has questions, answers, so on and so forth. And then there's a last thing wherein I ask the model to generate questions, generate answers, and then basis the answers, I give it a feedback to make it better. Like we do, we have these tests, right? You show me a random question, I try to write an answer, and basis the output, you will give me a score. And the objective of all of these researchers is to make sure that the reward or the score is maximum. And then we kind of went back to when we say, I'm talking to ChatGPT, who exactly am I talking to? And the answer was something along the lines, because they are pre-trained on the internet and then have been supervised, fine-tuned, or SFT'd on questions and answers, it is not very wrong to say that you are talking to an expert in that field who wrote that question and that answer. That's pretty much it. We also discussed briefly that the question answer dataset would not be the entire questions that human race could ever have imagined. And we kind of say that everything else is emergent, because it has seen a lot of theory. It is able to figure out how to answer questions. If I were to give you a simple example, it would be like, if I ask the model, who is Barack Obama? And definitely there'll be a thing in the dataset that says Barack Obama is the president of the United States. He was born in maybe Texas or wherever, and so on and so forth. And hypothetically, if I'm to ask it, who's Tanay Rathod? It knows the answer is supposed to be like, Tanay Rathod is something, right? So it kind of understands things like that. It kind of generalizes it to other domains. Okay, cool. And with that, we kind of concluded all of our theory part, wherein I was like, okay, this is what I wanted all of you guys to know. And again, I'll reiterate on the fact that if you don't remember anything from this session, just remember that what I can understand, what I can generate, I can understand is the entire basis of anyone creating any algorithms. Okay, let's switch gears and move to the application track, because this is not a research lab, neither this is a research presentation. It makes sense that we talk a bit about business right now that we have all decent level of prerequisites, right? See, whenever people talk about technology, right, one of the things that I like, I think it was coined by Steve Jobs or someone, it is like technology is supposed to be invisible, right? Your users don't care if the thing runs on an LLM, or if it runs on a swarm of humans who just look at your questions and give you answers. It is supposed to be invisible. And the only way to delight users is to think ahead, right? I was watching this talk on the AI Engineer YouTube channel, and it was by the product engineering head of Windsurf, and the talk was titled "Thinking 10 Steps Ahead of You." And if not everyone here knows, Windsurf was acquired by OpenAI for $3 billion recently, and I think it is one of the fastest growing companies in the world right now, after Cursor, of course. So how do you delight your users? It's by thinking 10 steps ahead of them, 20 steps ahead of them, maybe 30 steps ahead of them, right? Can you anticipate what I want before I even say it? Is how you will say that you have delighted a user. Right? If you are maybe I think everyone here would have worked on spreadsheets. If you select maybe a column that has a lot of numbers, it automatically suggests you that some formula, right? It is a level of delighting. Hey, if you select it, I was expecting maybe you would want to add a sum here or something like that. So this is the entire basis of what everyone is building right now, right? The agentic systems. Okay. So we had Agents V 0.1, right? Everyone is talking about agentic AI and all of these applications and all. We had Agents V 0.1, which were basically systems smart enough to take some decisions, right? Things like, let's say if I have to write a social media post, it could do things like search the internet for relevant keywords, find relevant articles, take some good things about them, kind of move it to a pipeline and then write a first draft of it. That was Agents V 0.1, which everyone still is using. What we're doing right now is kind of slowly moving to something like Agents V 0.2, wherein what we're saying is, hey, we have a bit more defined workflows and we also have memory. Okay, so let's say in a hypothetical scenario, I'm creating a sales agent, right? In the Agent V 0.1 framework, it could do things like prospecting, right? It could go to LinkedIn, it could scan their profiles, it could do things like, okay, this guy maybe is a product guy, I could sell him a product. Maybe if this guy is a technical guy, I could maybe sell him some sort of infrastructure service, so on and so forth. And would have done. It would just do it on repeat, and it would basically be a stateless machine. It doesn't remember anything. But with Agents V 0.2, what is happening is we can also augment these agents now with memory, which means they are like you and me. We could augment them with domain-specific knowledge. Maybe you could say, if this is a sales agent, he should have read at least 5 books on sales that maybe have some sales strategies, outreach strategies, how to write emails, how to prospect, so on and so forth. And now what's going to happen is when that agent is prospecting and it has memory, it could start forming associations like, hey, I remember Tanay. I saw him when I was searching for something else. And maybe Tanay is very, very good friends with Tarun, and I already am talking to Tarun. So if I am to reach out to Tanay, it's a better strategy to maybe email and ask Tarun for introductions, because it has memory. It is learning from these experiences. That is Agents V 0.2, right? Still very, very unstable, still very, very hacky. And then all we're trying to do is kind of see if this scales up, right? It has a lot of pitfalls. Okay. And maybe the last iteration of agents would be something like service as a software, which I think a lot of VCs have been talking about for the past year or so. And if anyone here follows venture capital, Sequoia has a very good blog on this. It is something like Generative AI's Act O1 or O1 Act for Generative AI something. And what they talk about is, let's talk about how software and SaaS is sold right now, right? Let's say you have a very good sales guy. You'll have to buy a Salesforce subscription. You'll have to buy some, I think there's a Read AI meeting note taker here as well. Okay, someone kicked it out. Nice. You'll have to buy some sort of summarization tool. You'll have to buy a lot of prospecting tools like Apollo, Lucia, Lemlist, so on and so forth. You'll have to buy a lot of email sending automation tools. So you have this base salary, and then you're augmenting that person with a lot of tools, right? So let's say your base salary was 10 lakhs, and then you'll maybe spending 1 lakh easily on subscriptions. And a subscription to all of these fancy tools. And every year you'll have to promote that 10 lakh guy to maybe 5 to 10%. You'll have to give them that time, which means you're raking costs as you go up, right? What people are saying is, can I not create a sales agency, staff it by AI agents, and then compete with real sales agencies, right? Because the cost of running these agents is going down significantly. The models are improving multifold. I mean, every iteration brings out newer capabilities, newer functionalities in all of these models specific to tool calling and all. And I just replace that sales guy with an agent, and then I'm happy. The catch here is, instead of buying subscriptions for humans, you'd have to buy subscriptions for these agents. Things like you'll have to give them access to internet search. You'll have to give them access to APIs of, things like Apollo and Lucia and so on and so forth. So this is net where we are heading, wherein we are saying, hey, we don't need humans as such. We'll replace every human with a bot, and that bot will have memory, that bot will have domain expertise, and that bot will be able to do the same actions a human is able to do, with maybe being 100x cheaper, with not taking any sick days, travel days, so on and so forth. And that is the highest form of delight. And I think even Y Combinator has this thing open, and I think if anyone has similar ideas, you can just go apply to Y Combinator, see if they give you $500,000. Okay, let's maybe talk about pitfalls, right? So the biggest pitfall here is the compounding errors, right? Let's say a very simple example that I want to give you is just maybe a sales example, right? I think because everyone here understands sales. धंधा तो पता ही होगा सबको. So let's say you want to reach out to me, right? I am Tanay Rathore, and what your agent will do is you want to send me an email, customized email. You will go something like your agent will search for Tanay Rathore on the internet. He'll try to find some profiles, and based on the profiles, he'll try to personalize it. What if it found the wrong Tanay Rathore? Right? I am a Tanay Rathore. I work at ProBlock. And what if it found another Tanay Rathore that maybe is, I don't know, a chemist? The email will be personalized wrong and it will be sent to another person, right? So one small error in one part of the workflow nukes the entire workflow. It compounds like crazy, right? You have planning and reasoning gaps. So by planning and reasoning, I mean these models are still not able to do very, very sophisticated stuff, wherein it requires a lot of decision making, right? I think one of the problems that even we worked here internally was, can I look at a web page and then find out what parts of code need to be changed to make the web page faster? Like we tried with a lot of models, and then finally we said, hey, the models are not very capable enough. They can definitely look at some data. They can definitely do some basic math analysis. This page takes the longest time to load, which is why this is where I need to focus my attention on. But they're still not able to get past these level 1 analytics. They cannot think. They cannot do things like I see that this page is loaded every time. This component is loaded every time, and it will say because this is taking 5 seconds to load, I should just remove it. It will not look at and say, hey, this is the entire CSS that powers the web page. Right? Without this component, the web page would look maybe like IRCTC, like very blank, very old, lot of things. So these models still suffer from that pitfall. And again, I think I touched upon this when I first started, cost and scale. How do you scale this up? Right? Do we need to have your own LLM? Do we need to outsource this? Or how do you handle a lot of these component requests? Because even when I started my founder journey, initially I was like, these systems are almost free. But once we hit that scale, once you hit 1,000 users, 10,000, million, 10 million users, you start to see builds coming in. I remember, the bills used to go in lakhs, like 60, 70 lakhs per month was like a very, very normal thing. Just to support a couple thousand users every month. So these costs rake up very, very fast. And the thing is, how do you even price it given that ChatGPT gives out a subscription for $19? Like they can afford to lose money, but you cannot. A lot of rappers have made some money, but then people have now become a bit more price sensitive. So those were some of the pitfalls. And again, future ahead is like kind of open to interpretation. We could have something like universal basic income, which says because I said that agents will be doing all of that stuff, there'll be nothing left for humans to do. So we just sit, and government is supposed to send all of us a fixed amount of money so that we can buy utilities, do some sort of stuff. Or maybe it could be something like intelligence brake cards, which a lot of people are warning us against. I think all of you would remember when there was like a petition which was signed by which was signed by Elon Musk and a lot of big leaders saying we need to stop all research that relates to LLMs, because a lot of people are afraid hey, what if these systems become super capable or super intelligent and then end up destroying humanity. So who knows? Or there could be a third future. I don't know. It's just speculation. So with this, I would like to conclude my talk or my one-sided blab or rant, and open it up for you guys to ask some questions if there are. You can put them in chat. I think Tarun can monitor them.
We are still waiting for questions. So Anjana, Karanveer, Ajay, Bharat, Purnima, look forward to your questions.
Yeah. No questions?
No questions.
Can you maybe mute the non-speaking guys?
Yep, Tanay, I think mostly good to go.
Okay.
Okay, I think, hey, Anjana has, I think Anjana had a question. That's why they're muted.
Okay.
Hey, Anjana, do you still have a question? I think we'll just give it one more minute and then we'll be mostly good to go.
Sure.
I think yes, stage 3 had the last question, and Neeraj is asking what are the biggest bottlenecks Gen AI devs are facing in fine-tuning models for specific use cases. Oh my.
That's like a very, very technical question, but I'll try to answer it in a very EL explain like I'm 5-way. Just give me a second to think. Okay, so let's say you have a basic ChatGPT model, which maybe has a score of 10, right? Just by prompting, you can give it fancy prompts. There are a lot of prompt generators that you can just give it fancy prompts, and let's say you are getting a score of 10. It is very likely that even after you do a lot of fine tuning, you end up with a score of 11, right? So fine tuning is not giving you like that level of performance boosts, given that these models are now becoming very, very general. A simple example would be, I think if you remember in 2022, OpenAI had a code-specific model called Codex. A lot of people had domain-specific models. But now what we're seeing is all of these models converging to just, one single mega model, which can do everything, which can do image recognition, to text generation, to audio generation, to code generation, to all of these things. So specific use cases, yeah. I mean, if you were to ask me, I would just say maybe go with the prompt first. See what sort of performance you can squeeze from just the prompts. There are very good libraries like DSPY who allow you to optimize these prompts in the latent space, which give you very, very good boosts. And then let's see. Fine tuning is also very, very simple. I mean, you can just spin up a free Google Colab notebook and then, end up with a good model. I remember one of my friends fine-tuned GPT when it was there, GPT-3, base GPT-3, I think 2021, or maybe it was a Medium blog or something. He or she fine-tuned it on piano notes, right? And then the model was able to generate coherent piano notes, and then he or she was interpreting that to audio, and then you were like, hey, GPT is also generating audio now. So you could do fancy stuff like that. I hope that answers your question.
Sounds good. By the way, Prabhu has a very simple question actually compared to this. What can be the career opportunities in this field, and do we need to study specifically anything?
Okay. I think this is a harder question than the previous one because
But a simpler one.
yeah, okay. I mean, so there are two sides of it, right? There are two sides of machine learning engineering. One is applied and one is research, right? If you are to go to the research side, I would recommend you need to read a lot of stuff, right? You need to understand math. You also need to be up to date with, research papers, how people are doing stuff, how they are training, fine tuning, what are some current strategies. You need to be maybe decently good with deploying these models, the ones that you build on. The other side of this is applied machine learning, which is almost very, very simple if you are a good software developer. All you need to do is you need to figure out how these APIs work. You need to figure out how these prompts work, and then you can just hack together a model that does some stuff. Like the sales outreach model, right? You do not need to know how these models are built. You do not understand how they are served or anything. All you need to do if you are building that agent as an engineer is I just give a prompt, hey, this is the LinkedIn profile of that person. How do I do this? And you can just pipe it and then give the final output.
Okay, interesting. Similarly, I think she's asking that should I use an existing GenAI tool
Hmm.
or build a custom model from scratch? What are the trades-off? I think this is a more generic one, but just
I
want to
think
take the generic
I think the simplest question I've ever asked so far, anyone has ever asked so far. I would not recommend building a custom model to anyone. Start with OpenAI API. They also have a fine-tuning API wherein you can do a basic fine-tune of the model that you want to work on. I would not recommend anyone go that route because again, see, if this was 2022, I would have said, hey, you need foundation models that are good, that do this, do that. I think there was also a class of models that came in around that time. I think Salesforce released a coding model. I think it's called Star Codex or something. Then Bloomberg had a Bloomberg GPT. Then you had a lot of other people building other use case specific models, and I think that was the end of it. No one today is building case specific models. Everyone is mostly relying on OpenAI, Gemini, Anthropic, so on and so forth.
Okay, makes sense. I have a simpler question. I think because this is something that I've gotten a lot from outside the chat. But what are some kinds of different? Oh wow, yeah. I think first we'll ask the best question, which is what are different career paths in Gen AI?
Okay. I mean, prompt. Okay. So you have. I mean, again, like I said, right? You have the research side of it, and then you have the applied side of it. Applied side, you'll have MLOps. Applied side, you'll have LLM, generative AI engineers. You'll have full stack AI developers, sort of guys who can integrate front end, back end, these APIs and all of these things, right? On the research side, you'll have safety guys. I mean, research guys have like no actual deliverables except like figuring out how these systems. Okay, I'll give you a better analogy, right? I think everyone here has studied maybe 9th class chemistry, wherein people were like, plum pudding model was the first model of the atom, and then people like, this makes sense. But then I think other did a Goldfall experiment, and they were like, no, this is not what it looks like. This is what it really looks like. And then I think Bohr gave another model, and people like, this makes more sense because the wavelengths and all match. And then we had Schrodinger who gave a model I think no one understands, right? The 1s1, 2s1 sort of like the wave duality sort of model. So we are right now with generative AI, we are there, which is why we need a lot of researchers to work on a lot of smaller statements to help us understand what exactly is the state of that thing, because we still don't understand. And I think it's been 2019, 21, 2, 3, it's been like 6 odd years. We have had these LLM class models, which we know are able to generate stuff, summarize, translate and all, but no one knows why. The problem with not knowing why is we won't know why it broke, right? If something is working magically and it breaks, you won't be able to debug it. It's the overall idea. So we need researchers to know. So here you have safety guys who make sure these models do not escape. You have data guys, the guys who scrape the entire internet, create that data. You have fine-tuning guys who take these, predefined question and answers and feed it to the model. You have ML performance guys who make sure that the code is running as efficiently as possible. You have MLOps guys who make sure these things are auto-scaled, like you can attach 16,000 GPUs or 20,000 GPUs onto a single cluster. You have networking guys who make sure these systems communicate effectively, right? You need to have, as you start scaling, you start to see a lot of problems. So you have like different people for different stuff. So again, broadly two parts. You have research and then you have applied. Applied guys have nothing to do with any of it. You just take the API and then you treat it like not the software engineering, which I think has most jobs right now because not everyone is hell-bent on creating their own foundation models, right? So research guys mostly work at, OpenAI, Anthropic, Google, Microsoft, Salesforce, maybe Sarvam, Kratim sort of companies. Applied AI guys you'll find everywhere. Any AI startup which is indirectly an OpenAI or any sort of similar thing wrapper, you'll have these applied AI guys. Hope that answers the question.
Perfect. And I think one last question from my side that I've got from outside the chat box is actually, what are the different emerging trends that you are seeing in this space as someone who has been involved in the last 10 years? So what do you think are the more emerging trends in this space, and where do you think this industry is headed in the next 5 to 6 years, I guess?
I think reasoning is a very, very good thing that we are working on right now. You have these O1 class models, right? Models that can think, right? And models that can self-correct. So that is there. And I feel, we still haven't solved for a couple of small things, right? I was reading this book, it's called why machines learn or how machines learn. This by a guy named Anil Anandaswamy. He spoke about a guy, I forgot his name. That guy won a Nobel Prize in late 80s or early 90s, and he pioneered something called the idea of imprinting. Right, so they had duck-like birds. I think they're called sterlings. What this guy used to do is, the moment a sterling was born, he used to go to them with a maybe, let's say, yellow circle. And what that bird used to do is follow that yellow thing wherever it went. So he initially thought, hey, maybe it's recognizing the color yellow. And then he put maybe a yellow circle and a yellow square. And then he let the sterling be put the sterling in center, and then saw here the bird is still going to the yellow circle, which meant it is also recognizing shapes. And he did a lot of these experiments. You can just go look up imprinting and find what it is. The reason I'm giving this example is because even after so much supercompute that we have today, our models are not able to do imprinting as efficiently or simply as that sterling that was just born. Right? So that's the thing. There are a lot of people who have benchmarks like ARC. ARC is abstraction for reasoning corpus. It's like you give it simple, 5th, 6th level puzzles key. This is a frame. If I apply gravity to this, everything will fall. So that will be the second frame. It will show 2-3 examples and then be like, can I solve it? People are still not able to solve this problem, which is why there is a lot of debate. Are these models smart? Are these models generalizable? Or are they even doing this thing called in-context learning? So pretty much we are, I think, going towards trying to solve for that general singularity, wherein we say these models are smart enough to do stuff. Okay, maybe a better example would be something like, we are still at a human level, right, of these models. We want to go superhuman, right? Like, so we are trying to make that leap from human, because we are right now, these models are as good as their data annotators, right? That's what we discuss. Whenever you're talking to an LLM, you're talking to someone who wrote that prompt for you with their answer. That's what pretty much happened. But how do you get past all of this, and then how do you make it superhuman is the bigger trend that I see people moving towards.
Interesting. That actually makes a lot of sense, Tanay. Thank you so much for today's session. I think everyone here enjoyed it. I think Shri, Purnima, Bharat, thank you so much for joining. I do realize there was a hiccup in the middle, but so glad that you guys could make it back. Yeah. So yeah, we'll be doing this these series continuously. Maybe next time slightly not technical, so that a lot more people can have their questions answered. But yeah, Internet, any thoughts, any last comments before we end this session?
I mean, that's pretty much it. I just say future is bright and I'm looking forward, because the speed of innovation here like super high. There's a very good blog by Tim Urban on super intelligence. I would recommend everyone read this and realize we are at almost at that inflection point.
Okay, makes sense. So folks, thank you so much for joining in today, and we'll catch you guys in the next one.